After you said
Yeah,
that.
okay.
So, where are we? We've got these four kinds of functions. Okay, now the whole point is, as we know from the first exercise we did, if we've got 3 data points, we've got 3 points, we get 3 equations, right? And incidentally, not everybody doing this right. Better go back and review that a little bit. And there are 3 parameters, A, B, and C, right? Our points have the t and the y values. Okay? So if we have 3 equations, we find that we can solve these equations and find A, B, and C, right? We did that first week. Make sure you review it. It'll be on the, especially you're going to take the midterm thing, but you're going to need it whenever you get tested over quadratics, because it'll be on the next test too, after that. Okay? Here, as you experienced last night, if you've got 2 points, you can find A and B, right? You know, as we did in class last time. You only need 2 points because you've only got 2 parameters. You know, y and x are coordinates of your points. You don't have to find them. Yeah, I mean, maybe you have to find them by observing them, but you're going to use those points to find the values of A and B, right? And you could do the same thing with y equals mx plus b. If I give you 2 points, now, I've had you use fundamental triangles with the 2 points and all that stuff, right? And we kind of focused on that when we did the linear equations. But you could also, if I gave you 2 points, plug the values in for x and y and get 2 equations, and you could solve those equations for m and b. Much the same way you solve these equations, except much easier because there are only 2 of them. Okay? So, again, you got 2 parameters, 2 equations, 2 points. Now, if you just had y equals b to the x and you were given 2 points, and unfortunately, due to my bad, that's what you were given on the first problem, you end up with a contradiction. Okay? Now, one particular contradiction was y equals b to the x, and the points were 2, 5, and 0, 6. I think those were the points. Okay? Well, you plug in 2, 5. Okay, x is 2, so you have b to the 2nd power. Y is 5, so you have 5 equals b squared. That's easy to solve. B is square root of 5. Actually, it could be plus or minus the square root of 5. Yeah, plus or minus isn't written in there very well, but okay. Whichever it is, okay, your second equation, you plug in 6 for y and 0 for x, you get 6 equals b to the 0, right? And you plug b equals square root of 5 in there, or negative square root of 5, it doesn't matter. What do you get? What's the square root of 5 to the 0 power?
1.
Well, I certainly hope everybody understands that the 0 power of any number is 1, right? So it wouldn't matter whether this is plus or minus the square root of 5, you'd get 1, right? Making your equation 6 equals 1. Perfect. What are you going to do about that? You're going to say, well, if I did everything right, I got a false statement. It means that the problem was improperly posed. And in this case, I'll blame it on the program, except I wrote the program and I put the problem into the program, so my bad. Okay? It should have been a b to the x. I even, last class, your witnesses, wrote down a note to fix that, and I posted it and didn't fix it. Okay.